Continue with ellipse. The first important point about ellipse is the standard equation of ellipse, which is given by x square by a square plus y square by b square is equals to 1. It is made like this. This is the standard equation. This is the standard form of the ellipse. I'm sorry, I'm not that good at drawing, so you have to consider this. Okay, so this is the ellipse. Here, these two are the vertices. These two will be the focus. This is the center of the ellipse, and this will be the vertices of y-axis. So here a is greater than b, then this will be formed. If a is less than b, then this will be formed. Okay. So if a is greater than b, then it will lie on the x-axis. If a is greater than b, if a is less than b, then it will lie on the y-axis. It will be like this, oval at the y-axis. If a is greater than b, then it will be oval on the x-axis. Okay, so I'll move on. First of all, the relation between b and a is b square is equals to a square 1 minus e square, where e is the eccentricity of the ellipse, which is less than 1 for an ellipse, greater than 1 for hyperbola, which we have discussed. So this is the relation between b, a and eccentricity. Then it can also, eccentricity can also be written as 1 minus b square by a square. As b is less than a, so this is somewhat intuitive. Fine. This is the eccentricity. It is between 0 and 1. Okay. Now the directrix. In the case of circle, it was something. In the case of parabola, it was something else. X plus a is equals to 0. In this case, we have two directrix. So two directrices. X is equals to plus minus a by e. Fine. So this is the directrix. The two directrices. Then focus, or you can say foci. Foci will be plus minus ae comma 0. That will be less than a. Fine. So you can easily see that because e is between 0 and 1, so ae will be less than a. So if this is minus a comma 0 and this is a comma 0, then this will be a comma 0 because a is less than a. Why? Because e is less than 1. That's why this, and that's why this. Focus will lie inside the ellipse, not outside the ellipse, just like the hyperbola. We don't have this case here. So now foci is this. Then we have vertices. Of course, I told you a comma 0 and minus a comma 0. This is called a. Let's say this is a dash. Fine. So these are the vertices, or you can say vertex. Then we have the lattice rectum, which is given by 2b square by a. Lattice rectum, which is given by 2b square by a, is equals to 2a 1 minus e square. This is the lattice rectum, or you can say length of the lattice rectum. Lattice rectum is actually a length, so that's why it is 2b square by a. Fine. So these are the formulas, easy formulas. Then we move on to the auxiliary circle. Auxiliary circle. It is given by x square plus y square is equals to a square. Same, not the same as the circle. In the circle, it was x square plus y square is equals to 2a square. But in this case, we have a square. So for an ellipse like this, if this is a comma 0 and this is minus a comma 0, this circle will be like this, touching a and minus a, because they satisfy this equation, x square plus y square is equals to a square. This is the circle, auxiliary circle. So these 2 points will satisfy this equation, and the auxiliary circle is made like this. This is the y-axis extended, this is the x-axis. Fine. Now we'll move on with the parametric representation of an ellipse. Parametric representation of an ellipse, the points can be given by x is equals to a cos theta, y is equals to b sin theta. Why? Because the equation is x square by a square plus y square by b square is equals to 1. So when you do x square by a square, that will be cos square theta plus sin square theta, y square by b square sin square theta. That is always equals to 1. So this is the parametric representation of an ellipse. Now we'll move on with the position of a point with respect to ellipse, that is outside, inside, or lying on the ellipse. So the point, let's say P x1 comma y1 lies outside, inside, or on the ellipse if x square plus y square x square by a square plus y square by b square minus 1, this thing